with your appreciation of the enterprise network topology, we are comfortably in a position to look at ways how to simulate FTP scenario, for instance, for that network. In this module, we shall recall our understanding of modeling and simulation to look at the simulation for FTP by assessing the factors which affect the goodput. We would refer to the INET framework once again. We would be keen to determine what all factors must be included in the event log. And finally, what statistics are we interested to model? Again, this is the real world scenario in which the FTP server is lying as a bastion host with the stub router. The users could be from the outside world, that is the internet, or could be from within the network. The factors which affect the goodput are very important to be understood if we want to assess the performance of FTP communication session for the users both from within and outside the network. The first and foremost is the error rates. The protocols which are being used and invoked by FTP. For example, as we all know, FTP uses TCP, which requires handshaking, windowing, and uses sequence numbers and acknowledgements. The parameters which we adjust would also have a direct effect on the FTP session performance, including the frame size, the retransmission timers. The performance of the networking devices in terms of packets per second is also critical, and their loss rates. On the end sides, the workstation and server performances also have a direct implication on FTP session performance, which include the disk access speed, the caching size, the performance of the device drivers. The internal architecture of the buses which are being used in these end devices also has an important role to play. The processor which is used by these end devices, the memory utilization and its efficiency, the operating system which is being used, and the application itself which is carrying out file transfer from the client end and the server end. Although there are numerous parameters, but for the sake of simplicity and brevity, we could choose parameters which we can easily simulate. For that, you need to refer to the source files which are available on this given URL, and we'd look at the network or the NED file which we are given there. Here you can see that we just have a single router, 3 clients and a server. You can extend this given NED file to emulate the real world scenario that we just saw. This scenario uses bulk data transfer. Bulk data transfer means that the client sends a request for downloading a very large file and the server complies. Here, the bulk transfer uses the standard host. It is a compound module, the network configurator that configures the basic settings for allowing IP version 4 communication to take place, and the router settings. In order to implement a simple FTP scenario, some settings could be done very easily in the given code. For example, the number of requests per session could be exponentially distributed with a mean 3. The requests, of course, is much smaller than the response, so the request length is set to be around mean of 20 bytes and standard deviation of 5, and the reply length has to be very large, and it is exponentially distributed. If you are interested in assessing how good or bad the FTP scenario is doing, some questions must be asked. What is the total time to transfer the file, how much of the total traffic was wasted, as in bad put, what is the overall utilization given that the network is bounded by the capacity, what were the delay variation, and others, of course, the usability, scalability, and availability of the FTP scenario, all can be modeled. For that, using the INET framework, given bulk transfer example, certain parameters could be tweaked with, which are given here, including the local address, port number, data transfer mode. In FTP, of course, it is byte count, the number of requests per session, the request and reply lengths, the overall response time, and in case of timeout, the reconnection time. FTP scenario could be assessed in Omnet++ for the given bulk transfer NAD scenario. We see that we can determine the number of sent packets and the number of received packets. We can also measure the end-to-end delay and the total number of sessions which were actually utilized to transfer these files.